Hello, class. Today we're doing Unit 2, Lesson 4, dealing with properties of division and exponents. So starting off problem number 1, we have 8 to the 9th power over 8 to the 7th power. We were taught with this formula right here that the bases are the same on both top and bottom, that we're allowed to subtract the bottom's exponent power from the top. So x to the a over x to the b is the same thing as x to the a minus b. In other words, top exponent gets to subtract the bottom exponent. So that's what we're going to do here. So 8 to the 9th over 8 to the 7th is the same thing as 8 to the 9 minus 7, which equals 8 to the 2nd power. So that's great for exponential form, but they want us to write it in standard form. So 8 times 8 equals 64. Problem number 2. We have 7 to the 5th power times 7 to the 3rd power over 7 to the 2nd power. So this one follows our format B, where base raised to an exponent times base raised to an exponent again, and these are the same bases. We're allowed to add the exponents. So rewriting this, 7 to the 5th times 7 to the 3rd, 5 plus 3 is going to equal 7 to the 8th over 7 to the 2nd power. And now this falls back into our dividing with exponents. Top exponent subtracts the bottom exponent when the bases are the same. 7 to the 8th over 7 to the 2nd is equal to 7 to the 8th minus 2, which equals 7 to the 6th power. So now that's kind of a big number, so I'm going to use my handy dandy calculator to work this out. So I'm going to type in 7 exponent 6 equals, and we get 117,649. Problem number 3. C to the 22nd power over C to the 10th times C to the 5th power. So now we need to do that same kind of process we did on problem number 2, where we combine the exponents with similar bases, but now we're going to do it when it's on the denominator. So I'm going to rewrite this: C to the 22nd over C to the 10 plus 5, which is 15. Make sure you guys can see that on your screens at home. I think so. So now, again, we can follow this top formula. Top exponent subtracts the bottom exponent when the bases are the same. So 22 minus 15 equals C to the 7th power. Next, let's turn our little friend here. And we're getting even closer. Perfect. Problem number 4. We have Q to the 5th power over 6 to the 3rd power Q to the 2nd power. So now this one's a little bit different because we have 2 different items down below in the denominator section. So it's not just Q's above Q's. Top exponent still subtracts the bottom exponent. 5 subtract 2 leaves me with 3 on top. So what's left in the numerator's position, which is the top half of the fraction? We have Q to the 3rd power. And what is left on the bottom? 6 to the 3rd. And this eliminates out to a 1, technically. So 6 to the 3rd times 1, still 6 to the 3rd power. But to write this again in standard form, from exponential form, we're going to leave this top, Q to the 3rd power, and then 6 to the 3rd power. So 6 exponent 3, and we get 216 for our denominator. Problem number 5. We have 4 to the 10th power, P to the 3rd power over 4 to the 10th power again, and then just a lonely old p. 4 to the 10th over 4 to the 10th. Same base, exponents can be subtracted. 10 minus 10 is 0. And we talked about this on one of the last videos. Anything, no matter what x is, even if it's 4, anything raised to the power of 0 equals 1. And if you looked at this, looking at just the 4 to the 10th over 4 to the 10th, anything divided by itself also equals 1. So I'm going to go ahead and just scratch these out. Since we are multiplying, 1 times p to the 3rd, still p to the 3rd. 1 times p to the 1st power, still p to the 1st power. So I can scratch those out. P to the 3rd over p. With no exponent written, hopefully you remember that's a 1 up there. P to the 3rd over p to the 1st, 3 minus 1 is 2. So our answer is p to the 2nd power for problem number 5. Problem number 6. A to the 2nd power, b to the 3rd power, c to the 9th power, over b to the 2nd power, c to the 5th power. A doesn't have anyone to play with down below. B to the 3rd, it's got partner down here. B to the 2nd, c to the 9. It's going to deal with c to the 5. A squared, it's going to come on down. It's going to be part of our numerator. Numerator, denominator, 3 and 2. 2 are going to come away from this 3 and leave it with a 1. 5 is going to come away from here and out of here. 5 taken away from 9 is 4. So what's left? A squared, b to the 1st power, which is just b, and then c to the 4th power. Hopefully that looks nice. A little bit tilted down, but it's okay. So that is our problems for Unit 2, Lesson 4's homework. Thank you very much.